Students, welcome once again to your mathematics class. In our previous class, we all have discussed the fundamental concepts of trigonometry, how trigonometry and what are the basic terms which are associated in trigonometry. Also, we discussed the 6 trigonometric ratios and how are they defined. In today's video, we all are going to discuss few selected questions from the first exercise, that is exercise 8.1 of the NCERT book, to know how to apply the concepts of trigonometry while solving the different types of questions. So let us take the first question. The first question says, in triangle ABC, right angled at B, AB is 24 centimeter, BC is 7 centimeter. We need to determine the values of sine A, cos A, sine C and cos C, where A and C are actually representing the corresponding angles. So for our convenience, I have taken a right angle triangle over here, in which angle B is a right angle as it is visible. And now, as we have discussed in the previous video, that to calculate the value of any of the trigonometric ratio, we should know all sides of a right angle triangle. In this question, the length of AB is given as 24 centimeter. The length of BC is given as 7 centimeter. So what we do at first is we try to find out the value of the diagonal AC. So we use the Pythagoras theorem. So in triangle ABC, if we apply Pythagoras theorem, then to find out the value of AC, that is the hypotenuse, we can write is equals to square root of AB square plus BC square. Now we know the numerical values of AB and BC, which we substitute over here. So we write 24 square plus 7 square, and then it will be equals to the square of 24 will be 576 and square of 7 will be 49. When we add both of them, we will get 625. We know that 625 is the square root of square of 25, so we get the value of AC as 25 centimeter. So now we got the length of the third side of the triangle as well, that is 25 centimeter. And now it's very easy to calculate any of these 6 trigonometric ratio. So if we start finding the value of sine A, we know that for any right angle triangle, sine of any angle is equals to the ratio of perpendicular to the hypotenuse. We considered this angle, so side opposite to that will be taken as perpendicular, side adjacent to it will be considered as base, and hypotenuse as usual fixed, that is opposite of right angle triangle, sorry, opposite of right angle. So sine A or sine theta we know is perpendicular by hypotenuse. Length of the perpendicular is 7 centimeter. Length of the hypotenuse is 25 centimeter. So the value of sine A will be 7 by 25. Same way, if we try to find out the value of cos A, we know that the value of cos A is base by hypotenuse. So the length of the base here is 25 4 centimeter and the hypotenuse is 25 centimeter. So it will be equals to 24 by 25. In continuation with this, if we go for the second part, and now we need to consider angle C. So when we consider angle C, for angle C, the side opposite to angle C will be taken as perpendicular, adjacent side will be taken as base, and the hypotenuse remain as it is. So you can see with the green color, I have shown the positions of perpendicular, base and hypotenuse when we consider angle C. Now if I have to calculate sine C, it will be again equals to perpendicular by hypotenuse. For sine C or for angle C, perpendicular's length is 24, so it will be 24 and hypotenuse is 25. Same way, if we go for the next part, that is cos C, it will be equals to base by hypotenuse. Base for C is 7 centimeter, hypotenuse remain as 25 centimeter. So in this way you can see we can find out the value of any trigonometric ratio for any of the acute angle of a right angle triangle if we know the measurement of all three sides of the triangle. So this is how we can solve this first question. I hope this must be clear with everyone. Now we are moving towards the next question. So the next question is question number 3, which we have taken in this video. It says if sine A is equals to 3 by 4, calculate the value of cos A and tan A. So see over here in this question, the exact measurement of the sides are not provided. Why am I telling you this? Because in examination or while solving this question, many times the students do mistake. What the mistake is, I'll tell you in a short while. First of all, it is given that sine A is 3 by 4. So for our convenience, you can see I have created or I have drawn a right angle triangle in which this angle is taken into consideration because sine A is given. Angle C is 90 degree. So for sine A or for angle A, AC will be acting as the base, AB will be the hypotenuse, and perpendicular is BC. Now the value of sine A, we know that sine theta is the ratio of perpendicular and hypotenuse. Now listen carefully. Sine theta is a ratio, and we all know that the ratio is always written in simplest form. What I mean to say from this is, many a times what the students do, they see that sine A is equals to 3 by 4, which is the ratio of perpendicular and hypotenuse. So what they do, they take perpendicular as 3 centimeter, they take hypotenuse as 4 centimeter, and they continue with their further calculation, which is incorrect. Why? Because 3 by 4 is the ratio of perpendicular and hypotenuse. They are not their exact dimensions or the lengths. There might be a possibility that sine A was calculated for a triangle whose perpendicular was 6 centimeter and a hypotenuse 8 centimeter. In that case also, when you calculate its ratio, ultimately it will come as 3:4. So we will not take the sides as 3 centimeter and 4 centimeter. Instead of that, we consider it in the ratio form only. What we do, we will consider the perpendicular as 3K and hypotenuse as 4K. Recall when we were doing the simple equation, many a times it was written that two numbers are in the ratio 3:4. So we all were taking the ratio as 3K and 4K, or we all were taking the numbers as 3x and 4x. So x was the variable. Same way over here, we are taking the sides as 3k and 4k because this is not the exact value. So now we again use Pythagoras theorem in triangle ABC. If we use Pythagoras theorem to find out the base, that is AC, so now AC will be equals to square root of AB square minus BC square. Let's simplify it by putting their values. AB is 4k, so we will write 4k whole square minus BC is 3k, so we write it as 3k whole square. After the further simplification, it becomes 16k square minus 9k square. Now 16 minus 9 becomes 7k square, which on further solving gives you root 7k, because k square is there, so k can come out from the root. So we got the value of AC as root under 7k. Once we have obtained the third side also, we can calculate any of the trigonometric ratio for this particular triangle. So now we just have to calculate the value of cos A. So the first one is cos A. We know that cos theta is base upon hypotenuse. So cos A will be base, that is AC, upon hypotenuse, that is AB. By putting the values of these sides, AC is root 7k, AB is 4k. On simplification, when k will get cancelled out, we will get is equals to root 7 by 4. In the same way, if we calculate the value of tan A, we know that tan theta is perpendicular upon base. So tan A here will be perpendicular, that is BC, upon base, that is AC. The value of BC is 3k. The value of AC is root 7k. So will be equals to 3 by root 7. So this is how we can calculate the value of any of the trigonometric ratio if we know the value of any one of them. We can just use this following method. Even if we want to find out any other trigonometric ratio like sec, cosec and the others, we all can calculate all by using the same procedure. What you need to keep in mind, whenever the ratio of any trigonometric part is given, like sine A was given over here, we won't consider 3 and 4 as the sides of the triangle, rather we will take it in proportional form like 3k and 4k. So this is this question. Let's move on to the next question. So we took the fifth question now. It is sec 13 by theta is given as 13 by 12. We need to calculate all other trigonometric ratio. So once again, sec theta, for your convenience, the diagram is made over here. PQR has been taken as a triangle. Theta was the angle which was taken. So I took angle P as theta. So now theta is given for sec. We know that the value of sec theta belongs to what? I hope you all must now be aware that sec theta is the reciprocal of cos theta. Cos theta was base upon hypotenuse, so it will be hypotenuse by base. For this angle theta, this side will act as base. This is hypotenuse and QR will be perpendicular. So this is given as 13 by 12. So we can consider the hypotenuse as 13k and base as 12k, and then we calculate the value of QR once again by using Pythagoras theorem. So if we calculate, now I am writing it in a little bit shorter way. I'll just write QR is equals to square root of PR square minus PQ square. Once again, remember to take the variable. I have taken K, you can take any other variable, you can take A, X, anything. So PR is 13K whole square minus PQ is 12K whole square now is equals to 169K square minus 144K square. On simplification it gives 25K square. So now we know that square root of 25 is 5 and for K square it is K. So we got the value of QR as 5K, and now we can calculate all other trigonometric ratios. So what are the other trigonometric ratios? They are, first one is sine theta. So sine theta is perpendicular by hypotenuse. Perpendicular is 5K, hypotenuse is 13K, so it will be equals to 5 by 13. Same way, if we calculate next one, that is cos theta, it is base by hypotenuse, so it will be 12K by 13K or is equals to 12 by 13. I am not calculating the further ones. You all can do it from yourself. You just need to write the numerical values for those particular trigonometric ratios. So by doing the same, following the same method, you all can find the remaining trigonometric ratios. Moving on to the next question. We took this question over here. It says if 3 cot A is equals to 4, then check whether 1 minus tan square A upon 1 plus tan square A is equals to cos square A minus sine square A or not. So what I need to do over here is to find out the value of tan A, cos A and sine A from the given information, and then we will put those values separately and left hand side and right hand side of the given equation, and then we find out whether they are equal or not when simplified. So let us begin. The first thing which is written here is 3 cot A is equals to 4. So from here we can find that cot A is 4 by 3. So for this right angle triangle, angle A is taken into consideration. So this is base, this is perpendicular, and this is hypotenuse. I'm writing it in each and every question so that you all can be well versed in understanding which side will be perpendicular, which side will be the base. Again, it is written in the form of a ratio. We know that cot theta is a base by perpendicular, so the base can be taken as 4K, perpendicular can be taken as 3K. Now I am doing it in a little bit shortcut way. When you calculate by using Pythagoras theorem, you will find the value of AC as 5K. You all can calculate it from your own now, because I think it is quite clear how to calculate the value of the third unknown side of a right angle triangle using Pythagoras theorem. So now we have got the value of all the all these sides. Now what we require tan A. So first of all tan A. So tan A is equals to perpendicular by base. Perpendicular over here is 3K. Base is 4K. So is equals to 3 by 4. We require cos A. Cos A is base by hypotenuse. Base is 4K. Hypotenuse is 5K. So is equals to 4 by 5. And what else we require? It's sine A. So is equals to perpendicular by hypotenuse. So it will be equals to 3K upon 5K and is equals to 3 by 5. Now we will put these values in the given equation. So firstly we will take left hand side, which is equals to 1 minus tan square a upon 1 plus tan square a. So now we know the value of tan square a and tan a whole square are both same thing, but it will not equals to tan a square. So either if we are writing it in this form or in this form, both are same. Remember this also. So the value of tan a is 3 by 4. So we'll be putting it over here, 3 by 4 whole square upon 1 plus 3 by 4 whole square. Let's try to simplify it further. 1 minus 9 by 16 upon 1 plus 9 by 16. Take LCM. 16 minus 9 by 16 upon 16 plus 9 by 16. This 16 and 16 will cancel. 16 minus 9 will be 7 upon 16 plus 9 is 25. So this is the value of left hand side when simplified by putting the values. And now we will try to simplify the right hand side as well. So now we will substitute the values in the right hand side. So right hand side we have cos square a minus sine square a. So the value of cos a is 4 by 5. So it will be 4 by 5 whole square minus sine square a, that is 3 by 5 whole square. So it is 16 by 25 minus 9 by 25, or is equals to 16 minus 9 by 25, which gives you 7 by 25. So from here we have obtained that left hand side is equals to right hand side. So yes, 1 minus tan square a upon 1 plus tan square a is equals to cos square a minus sine square a. So this is how we can verify also whether they are equal or not. So I hope you all must have understood the different types of questions which we discussed today. With this, we come to the end of the today's class. We will now meet in the next class with some more questions, with some more new concepts of trigonometry. Till then, happy learning. Jai Hind.